Right, good day, great learners. Welcome to our lesson. I'm Skulile Ngube, and this lesson is proudly brought to you by the Gauteng Department of Education. Are you ready for the lesson, great learners? I really hope so. Let's make sure that we have our books, learners, because remember, you are not supposed to just listen without writing, okay? Make sure you have your books with you. We're going to be drawing graphs, so you have your ruler with you there, okay, and your pencil. Make sure everything is ready with you there, okay? Even your calculator, you have your calculator with you, right? Okay, right. We have done we've done quadratic functions. We've done the hyperbolic function. Today we're doing the exponential function. Do you know the difference between these functions? Okay, the quadratic function is parabolic. Remember, we talked about concave up, concave down. And then the hyperbola is two arms, one on the first quadrant, then the other one in the third quadrant, and then the other one on the second quadrant, then fourth quadrant for the other one. Okay, right. Today we're going to look at exponential functions. Okay, what are real life applications of exponential functions? When you're saying something is growing exponentially, what does that mean? Have you ever seen something that grows exponentially? Let me show you, learners. Right, exponential functions are often used to represent real-world applications such as bacterial growth, population growth, or decline. Right, like we have in 2020, COVID-19 started. You remember that? And then the cases just went up. We are saying that the cases of COVID-19 what? Grew exponentially. Do you see the red graph? So the exponential graph is shaped like this red graph here. Okay, that is exponential growth. Okay, let me write something here. We have f of x is equals to x squared. And then I have g of x is equals to 2 to the power x. Which function here is an exponential function? Is it f of x or g of x? It should be g of x, okay? Remember exponential equations, okay? The x is the exponent. The x is the exponent. And then this is parabola. This is quadratic. X squared is quadratic. And then 2 to the power x is exponential, okay? Please don't forget that. I've seen learners making mistakes with these two graphs. I give them an equation like g of x is equal to 2 to the power x. Then they sketch a parabola. Okay, because they almost look similar, but if you check here, x is the base. For exponential functions, x is the exponent. Okay, right. Now, at the end of the lesson, you should be able to perform a point-to-point plot of the basic graph defined by y is equals to b to the power x. We're not going to do a lot of graphs, just we're going to concentrate on this one. And then we're going to talk about its key features. Right, and then we're going to investigate the effect of the base b on the exponential function where b is greater than 0. Okay, when the base, this is the base, remember exponents, this is b is the base. When the base is greater than 0, or when the base is between 0 and 1, when it's a proper fraction, like 1 over 2, 2 over 3, that's a proper fraction. Is it possible to have a base that is 1 and have an exponential growth? It is not possible. If the base is 1, remember 1 to the power anything is 1. So if the base is 1, then you're getting a horizontal line. It won't be exponential, okay? So the base must be greater than 1 or between 0 and 1, not 1, okay? Right. At the end of the lesson, we're going to look at the domain, which are the input values. What else? These are the x values. What else? These are the independent variables. Remember that. And then the range, the output values, which are the y values, which are the dependent variables. And then we're going to talk about the intercepts with the x's, the x and y intercepts, and then the shape as a result of change in b. Right, and then the asymptotes. But now we're going to talk about an asymptote because it's only one for this function. Right, pre-knowledge, equation of a horizontal line. We have to revisit this because an exponential function has a horizontal asymptote. So we must know how we get the equation of a horizontal line. We talked about the equation of a vertical line and horizontal line when we were doing what? Our hyperbolic function. Do you remember that? Okay, I want you to answer these ones. Right, I'll draw a red line, then you give us the equation of that line. Okay, right, what is the equation of this line? You answer there, don't write it down, just answer it verbally. What is the equation of this line? Y is equals to 1. Okay, because you see this point here is 0, 1. Let me pick maybe 2 more other points. I'll pick this one is 4, 1. You see that? I can pick here -3, 1. You see that? So the x is changing, but the y is not changing. So this line is y is equals to 1. Okay, you just check where the graph cuts the y-axis. Okay, and then say y is equal to 1. And then the next one should be easy for you. What is the equation of this one? Y is equals to -2. Good. What's the equation of this one? Y is equals to -4. Perfect. Perfect. So now we are going to be using this knowledge about the equations of what? Of horizontal line in today's lesson. Domain and range, we've talked about that, and substitution, we're going to use that in today's lesson. Okay, right, given the horizontal dotted line AB that passes through the origin, what is the equation of line AB? Just 1 minute. Answer the question, learners. Right, welcome back, great tense. Right, what did you get? What is the equation of this line, the dotted line AB? Where does it pass? At the origin. So the y value here at the origin is 0. So the equation here is y is equals to 0. I forgot to remind you about our WhatsApp line. Don't forget, learners, 079 454 9535. 079 454 9535. Remember, your input is very, very important. It will assist us a lot so that we can what? We can assist you. Okay. Like if you're moving fast, you have questions, you want to just show us your work, use the line 079 454 9536. Okay, let's interact during the lesson. Okay, right. Now, evaluate the following. Okay, I'm going to give you 4 minutes to do this. And then after 4 minutes, we're going to what? We're going to discuss. Let's say 4 minutes. Right, welcome back, learners. What did you get? Let's mark our work. The first one, 2 to the power 0. If the base is raised to the power 0, what do we get? We get 1. Any base to the power 0 is 1. Remember that, okay? And then the next one, okay, remember this law, exponential law. Let's say we have what? X over y to the power n. We're raising a quotient to a power here, and then becomes x to the power n over y to the power n. Do you remember that law? Okay, so we can apply it here and say 1 over 2 to the power 3 is equals to 1 to the power 3 over 2 to the power 3. Do you see that? And then what is our answer? 1 to the power 3 is 1, then 2 to the power 3 is 8. So we get 1 over 8. Okay, mark your work there. Let's go to C. Let's go to C. Right. Do you remember this law? X to the power negative n. It is equals to what? X to the power negative n is equals to 1 over x to the power n. Do you remember that? Okay, so it is the same thing we're going to use here. We're going to say this is negative, this negative. You see this negative, okay? And then 1 over 2 to the power 1. You see that, okay? Which is basically 1 over 2. You see that? So our answer there is negative 1 over 2, sorry, 1 negative 1 over 2. And then we have this one. Again, let's remember this. I'll start with this one. It said x over y to the power n is equal to what? Is equal to x to the power n over y to the power n. And then x over y to the power negative n. What do we do? Do you remember what we do? We invert the fraction, the base, which is a fraction. It becomes y over x, and then to the power n. Do you see now the n, the exponent is now positive. So we're going to do the same thing here. We invert 1 over 2 becomes 2 over 1. So it becomes 2 over 1 to the power 3. And then becomes 2 to the power 3 over 1 to the power 3. And then 2 to the power 3 is 8. 8 over 1 is 8. You see that? And then we have our answer as 8 there. Okay? Right? And then now, let's start plotting our function for a graph with the basic function f of x is equal to b to the power x. Right. Given f of x is equal to 2 to the power x. So now it means we're looking at a situation where b is greater than 1. Remember, we're going to look at two situations where b is greater than 1 and when b is between 0 and 1. Let's start with the one where b is greater than 1. Okay. How do we sketch our graphs? We usually have our table of values. Let's have our table of values. And then I want you to spend 3 minutes. You copy the table and you fill in the table after that. Okay. For 3 minutes. Let's try. Right, welcome back, learners. What did you get? Did you manage to fill in the table? Let's do it together. Right, the first one, let's find f of -2. F of -2. You see, where there's x, I put my input value. In this case, I'm going to start with -2. So f of -2, where there's x, you put -2, is going to be 2 to the power -2. We talked about this when we're doing our baseline activity. You remember that? So it becomes 1/4. Okay, can you put that as your output value then? Let's go to the next one. F of -1, it becomes 2 to the power -1. What do we get? 1/2. You see that? Put it on the table there. That's your output value. And then we have f of 0. When x is 0, it goes 2 to the power 0. What is it? 2 to the power 0 is 1. Okay, you see that? And then we have 1, f of 1. If x is 1, it's going to be 2 to the power 1, which is 2. We put our 2 there, right? And then f of 2, if x is 2, 2 to the power 2 is equal to 4. You see that? And then we have 4 there, okay? So this is our table, learners. Now we need to use our table to sketch our graph. Okay, let's do that. Now I want you to copy the Cartesian plane. If you can copy fast and then sketch your graph, continue to do so. But now you can draw your Cartesian plane. I'm going to give you 2 minutes and then we'll sketch the graph together if you want to wait for me. Okay, just 2 minutes. Draw the Cartesian plane on your book. Let's do it. Right, welcome back, learners. Let's sketch our graph together. Want to see how this graph is shaped. You see. Right, now let's look at our first point. Our input value is -2. Our output value is 1/4. Okay, our x is -2. Our y is 1/4. Okay, right, let's write it as what? As an ordered pair. -2 goes with 1/4. Right, depending on your Cartesian plane, if I'm using mine here, my 1/4 is 0.25. It's half of a half. So half is here. So it means 0.25 will be somewhere there. You see that? And then -2 is here. So where do they meet? Somewhere there. Okay, I'll plot my point there. This is the first one. I'll plot my point there. See that? I have my point there. Can you try to plot your point? Try to be accurate so that our graph will come out nicely. Right, the next pair, ordered pair, will be -1.5. -1.5. Right, -1 is here, half is there. Where should they meet? Somewhere here. Then we plot that point. Let's plot the point. Remember our WhatsApp line 079 454 9535. Right, this is our point. Where is the point? Here. Yes, it's there. And then we have this other one, which is 0 and 1. What do we call this point? The one where the graph is going to cut the y-axis. What do we call it? We call it what? Y-intercept. That's where the graph cuts the y-axis. X-intercept. That's where the graph cuts the x-axis. So now that's the point there. Okay. And then we have this one, 1 and 2. 1 and 2, 1 goes with 2. X is 1, y is 2. So it means this one here will be 1 and 2. This one is a clear point. They meet there. And then we have the last one, 2 and 4. You see that? 2 and 4. 2 is here. Then 4 is there. And then 2 goes up to there. And then that's the point there. Do you see that? Where is the point? Yes, there. Okay. Now we have our points. Now we need to sketch our graph. We need to sketch our graph. Let's do that. That's the next part. Now let's sketch our graph. Is it going to cut the x-axis? No, it's not going to cut the x-axis. It's going to be approaching it, like it's going to cut it or touch it, but it will never do that. Okay, so now the graph is like that. That is our graph, our exponential graph. Okay, do you see how it is shaped? Right, I want you to sketch. I'm going to give you 1 minute to finish sketching your graph. Then after that, we continue. Let's do it. Welcome back, learners. Right, I really hope you managed to sketch your nice graph. Now, from this one, I'll be showing you the graph, then you copy them. Now we know how to plot, isn't it? We can't continue plotting for every graph. So I'm going to be showing you, then we discuss the key features of the graphs, okay? Right, now, given the function of f of x is equal to 2 to the power x, I want to compare. Now I'm going to give you the other graphs and I'll give you time to copy them, okay? There is this graph, g of x, which is what? 3 to the power x. What has happened here? Our b has changed. Remember one of our objectives. We said we want to see the effect of change of b. If b changes, what happens to the graph? Do you remember that? Right. So the graph for 3 to the power x is going to look like this. That's the graph for 3 to the power x, okay? Now, and then I have another one. The graph for h of x is 4 to the power x, okay? And then the graph is going to be like this. That is graph for h of x. So now I want you to draw these 3 graphs. I'm going to give you 2 minutes for that. Remember to write the equations or the functions. This, and name them so that we know which one. The red one is for f of x, the blue one is for g of x, and the brown one is for h of x. 2 minutes, copy the graph, and then we're going to discuss the key features of these graphs after that. Let's do it for 2 minutes. Welcome back, learners. Did you manage to sketch your 3 graphs? Okay, let's discuss these graphs. What do you observe here? Okay, what do you observe? You can even discuss the key features, the shape of the graph, the x-intercepts, the y-intercepts. Okay, what else? Yeah, let's discuss that. The domain and the range, can discuss that. Okay, right, let me just lead you as we discuss, okay, so that we don't waste time. Right, now, as b increases, what happens? Okay, you see, the graph is like moving towards the y-axis. You see that? The red one, the blue one, moves towards the y-axis and then moves towards the y-axis. Do you see that? As b increases, the graph becomes steeper. Steeper. Okay? Right. When I'm comparing steepness, we say, let's say line AB, and then there's line CD. Which one is steeper here? Is CD, because the gradient is higher for CD. So now as B increases, the graph becomes steeper. Did you recognize that? Okay, right, good. Now, and then what about the x-intercept and the y-intercept? Let's start with the x-intercept. Remember the graph that we're looking at is the graph of the form f of x is equal to b to the power x. Just that. Okay, we haven't done the vertical shift now. We're just doing f of x is equal to b to the power x. Now, do we have any x-intercepts? Is there any way where the graph cuts the x-axis? I'm looking here, I'm trying to get it. No way. There are no x-intercepts. So the graph does not cut the x-axis, so there are no x-intercepts. What about y-intercepts? What about y-intercepts? What can you say? Where is it? Right, now the graph cuts the y here. What are the coordinates of this point? 0, 1. So it means f cuts the graph at 1 or 0, 1. G cuts the y-axis at 0, 1. H of x cuts the y-axis at 0, 1. Why? Why all of them? Because these ones are different. We have f of x is equal to 2 to the power x. We have g of x is equal to 3 to the power x. We have h of x is equal to 4 to the power x. But now, these graphs, all of them, they are cutting the y-axis at one point. Why? Because if you are finding the y-intercept, where there's x, you put 0. See, there'll be 0 here. And then any base to the power 0 is 1. Do you see that? So your y is going to be 1 for all the graphs. So the graphs of basic form f of x is equal to b to the power x. The intercept is 0, 1. X coordinate 0, y coordinate 1. Don't forget that. Okay? Don't forget that. So the y-intercept is where the graph cuts the y-axis, and then in this case it is 0, 1. Okay? All right, domain. Do you remember what the domain is? I think I need to give you time. Can you discuss the domain for 1 minute? After 1 minute, I'll come back, then I'll discuss with you. Let's do it. 1 minute. Welcome back, learners. I want us to go back a bit to the graphs that we have learned, because sometimes comparing things will assist us understand better. Do you agree? Okay, I want us to talk about the domain for the parabolic function that we discussed, and the domain for the hyperbolic function, and then I will introduce the domain for what? For exponential function. Okay, so we said for the graph of the form f of x is equals to ax squared. What was the domain for this? What is the domain for this? We said x element of real numbers, or we say x is element of negative infinity to infinity. Remember that? That is parabolic function. And then these are the domains. Remember, domain x is equals to. And then the hyperbolic function f of x, a over x. This is hyperbolic. Okay, where the x is the denominator. We say the domain is x element of real numbers, but x cannot be equal to 0. Okay, or we can say x less than 0 or x greater than 0. You can write it like that. And then the domain, oh, we have talked about the domain of those two. So what about the domain for an exponential function? Which x values can we put here? You see the arrow of this graph is going this way. It's not going to end anyway. It's going to the left. And then this side also is going this way. So what will be the domain? Again, the domain for this function is x is an element of what? Of real numbers. Or x is from negative infinity to infinity. Okay, you can even write the set builder notation here. Okay, for a set of x, so that x is between negative infinity and infinity. Right, but I just prefer these two. They're easy to write, the first two. Right, now, is it similar to the parabolic one? Check. You see? They're the same. The domain for the parabolic function and exponential function are the same. Even here, you can say x is from negative infinity to infinity. Okay, that is the domain for the exponential function. Please write the notes down. 1 minute, write your notes. Welcome back. I hope you managed to write a few notes so that you won't forget this. Right, let's go to the range. There's something that I have not discussed. I didn't forget it. Okay, we're going to talk about it now. Right, the range. Should we go back again to the parabolic? What? Okay, for f of x is equal to ax squared. The range was y less than or equal to 0 if a is less than 0, if the graph is concave down. But if the graph is concave up, y is greater than or equals to 0. You see that? 0 is included. Right, or you can say y element of what? 0 to infinity. If what? Please remember the conditions. If a is greater, when the graph is concave up, okay, when the graph is concave up, and then also y element of negative infinity to 0 if the graph is concave down. Okay, right, that is the range, but I will concentrate on this format. Right, and then for the hyperbolic, we said y element of real numbers, but okay, let me write the equation for the hyperbolic first. Okay, I'll write it underneath this. Okay, I hope you will understand that. So, and then y should not be equal to 0 for this function. F of x is equal to a over x. Do you remember that? Okay, right. What about the range for the exponential function? We say the graph is going If you look at this side, it's going down, but it will never touch the x-axis. Remember the equation of the x-axis. Remember the line we did under baseline activity? It was AB on the x-axis. What was the equation of that line? It was y is equal to 0. So it means this line, this graph is approaching the line y is equal to 0, but it will never touch it. So in the range, 0 cannot be included because it is not touched by the graph. You see that? So the range for this function is going to be y greater than 0, not greater than or equals to. Do you see this one? We said greater than or equals to or less than. No. This one is simply greater than or less than. 0 is not included. Okay? Or you can write it like this. You see this bracket, the round bracket shows us 0 is not included. The square bracket shows us that 0 is included. Or you can write it in set builder notation like that. Okay? That's the range. Right. I want us to see something here. If I may substitute a very small value, let's say negative 20. Negative 20 is somewhere this side. Okay? Do you see we have a value that is above 0? This one is showing you that as you go to your left-hand side, the graph is approaching the x-axis, but it will never touch it, and it will never cut it. So this imaginary line has a special name. What is it called? It is called the asymptote. So the graph is approaching this dotted line, which is the asymptote. And the equation of that asymptote is y is equals to 0. So don't forget that. Now we've talked about the shape of the graph in the form of graph of the form y is equal to b to the power x. Okay, we're going to see the other shapes very soon, but let's talk at that. Now we talked about the asymptote. Now y is equal to 0. We talked about the y-intercept. We talked about the x-intercepts. We talked about the shape and the effect of b. As b increases, what happens to the graph? Remember those key features. Okay, and then later on we're going to bring in the reflections and all those things. Okay, right. So this is called an asymptote. Y is equal to 0. So this one has one asymptote, right? Y is equal to 0 is an asymptote, which is a line that is being approached by a graph, but never touched or cut by it. Okay. Any questions? If there are any questions, please send them to 079 454 9535. Okay, right. Now, complete this sentence. As x value increases, the y value, what does it do? If you look at this graph, as x value increases, what happens to the y value? The x value increases as you go to the right. The y values increase as you go up. As we go to the right, are the y values going up? If you look at this graph. Yes, it is. If you draw a line like this, you know that. You see, remember when you're doing gradient for straight lines, when the graph is like this, the gradient is positive, showing that the graph is increasing. When the line is like this, the gradient is negative, showing that the graph is decreasing. So this one is taking this shape, or this one. So it means this is an increasing graph. As x increases, y increases. So that's the answer there. Okay? Right, that's an increasing graph. So now what can you say? If b is greater than 0, what type of a graph do we have? Is it an increasing graph or it is a decreasing graph? It is an increasing graph, an increasing function. Please don't forget that. If b is greater than 1, did I say 0? I think I made a mistake. Right, if b is greater than 1, b greater than 1, the graph is an increasing function. It's an increasing function. You're going to be asked such questions in the exam. Is this graph an increasing function, or where is the graph increasing, where is the graph decreasing? Don't forget that. Okay. Now we've talked about the value of when b is greater than 1. Okay, what about when b is between 0 and 1? We're going to talk about that. Okay, right. Now, this one, I'm going to sketch the graphs and then we copy the graphs, okay? Because we don't have time. Now, sketch the graph of g of x, and then 1 over 2 to the power x. If you check here, this b is a proper fraction, which is between 0 and 1. Even this one, g of m of x, is between 0 and 1. T of X is between 0 and 1. We want to see how is this graph going to be shaped now when B is between 0 and 1. Right, so now I got the output values and then I sketched G of X, which is this one. Now I sketched M of X, which is this one. See that, the blue graph? And then I sketched T of X, which is this one. Okay, the green graph. So we have the three graphs. I want you to copy these three graphs. Okay, just neat sketches. You sketch the graphs. Okay, they are passing through the point 0, 1. Don't forget that. And then they are not cutting the asymptote here. Okay, there's an asymptote here, so they are not cutting that asymptote. And then you write the equations, and then you name your graphs. Okay, you name your graphs. This is G of X, this is M, this is T. Okay, right, 3 minutes. Let's try to do that, and then after that we discuss. Right, welcome back, learners. I hope you managed to copy the graphs. Let's discuss. Okay, right, what do you see here? Are this graph increasing? Now it's like they are this direction now. You see that? Okay, these are like decreasing. You see that? Okay, so when B is between 0 and 1, the exponential graph is a decreasing graph. Okay, do they have the y-intercept? Yes, they are passing through the same y-intercept, 0, 1. Do you see that? Okay, what about the domain? Is it going to be the same? Yes, it's going to be the same. Let's just go through the notes that I've prepared. So we have here, there's something I was thinking, how can I explain this thing nicely? Because it's confusing. It's confusing. It's really confusing. I was also confused, but I think I got it. Right, now let's check half here. 1/3, 1/4. Which one is smallest fraction there? Do you know that 1/4 is the smallest? Okay. But now, how do I say this? Because in the previous discussion, you said that if b increases, the graphs become steeper. Do you remember that? But now it seems like when b is increasing, sorry, if b is decreasing, that's when the graph becomes steeper. Because you see the green graph, this one, t of x, is 1/4, which is the smallest, followed by m of x, which is the blue graph, and then 1/3, and then followed by g of x. Okay, so when it's a fraction, it seems like if b decreases, then that's when the graph becomes steep. And then, okay, I said, no, let me use my knowledge about exponential laws. Okay, this thing, I can write it like this. You see, this, I can write it like this. Do you remember that? And then this, I can write it like this. You see that? And then it becomes very clear now. 2, 3, 4. Okay, if they increase there, then the graph becomes steeper. So now, for this one, when b is between 0 and 1, it's better to look at the denominators of the fractions. As the denominators of the fractions increase, the graphs become steeper. Okay, the graph becomes steeper. I really hope it is clear. Okay, I tried. I know I tried, but it was difficult for me to explain this, but I hope you understand. Okay, look at the denominators. Just look at the denominators. As the denominators increase, then the graph becomes what? Steeper. That is for when b is between 0 and 1. When b is between 0 and 1. Okay, right. Then the graph is a decreasing graph. Okay, so the domain, we say the domain is the same. Okay, from x is an element of negative infinity to infinity, or x is a real number. Okay, the range will be the same. Okay, y greater than 0, because the graph will never touch the line y is equal to 0. So y is greater than 0. 0 is not included. You check, you see that 0 is not included. So it's the same domain and range as the previous one that you took notes for. Okay, so you can copy those notes and just paste them on this one. Right, and then the shape, if b is between 0 and 1, we say the graph is what? It's a decreasing function. It is a decreasing function. Okay, maybe this one you may have to write. If b is greater than 1, the graph is an increasing function. If b is between 0 and 1, the graph is a decreasing function. Just write that for 30 seconds. I'm not going to go anywhere. For 30 seconds, let's just write that. Right. Up, let's continue. Right, now the graph lies above the asymptote. Now, I want us to look at this. Okay, these two graphs. We have f of x when b is greater than 1. We have g of x. This is when b is between 0 and 1. Now, the only difference is this. Okay, let me write this one, rewrite it like in the other way. G of x is equal to 2 to the power negative x. Do you remember that? This and this is just one thing. Okay, so now the bases are the same. I want us to compare the bases here. This base and this base, they are the same. Okay, the only difference is that the exponent here is positive x, the exponent there is negative x. What is the difference here between the black graph and the brown graph? G of x and f of x. What do you observe? Anything is an open-ended question. Okay, do you see anything? I can see something here. Both of them, they cut the y-axis at 0, 1, but there's like a line of symmetry here. You see? So it means here, g of x is a reflection of f of x. About what? About the y-axis. The y-axis is the mirror here. So g of x is a reflection of f of x. So this arm is reflected, comes this side. This arm is reflected, it comes this side. Something like that. Okay? So this is a reflection about the y-axis. Right. What has happened here? We replaced x with negative x. So it means now this is a transformation. Do you remember that? Okay, did this in grade 9. Okay, when the coordinates x changes and becomes negative x, what type of transformation that's a reflection about the y-axis. So if f of x becomes f of minus x, of negative x, that's a reflection about the y-axis. Don't forget that. You see, the x here was replaced by negative x. And then let me just talk about this one. When f of x is changed to negative f of x, that's a reflection about the x-axis. Okay? Try to remember that. You can write these two and write your notes. The first one is a reflection about the y-axis. The second one is a reflection about the x-axis. If you check, f of x is y, isn't it? When y changes and becomes negative y, then it's a reflection. Let me pick any point here if you want to see that. Let's say this is 4, 3. If we reflect this about the x-axis, it will become here 4, here, it should be here. Right, becomes 4, negative 3. Do you see that the x did not change, but y is the one which changed from 3, positive 3 to negative 3. If I reflect it this side, along about the y-axis, it will come here to the left. So 4, 3, it becomes negative 4, 3. Do you see that this one? The 3 is not changing. What is changing is the y. Something like that. Okay? So remember that. Remember that. Right. So it's a reflection about the y-axis. Right. This is a question that I wanted you to try from a past examination paper. But now, because of time, I'll try to explain. But I'll move slowly so that those who want to be ahead of me, they will manage. Okay? I've shown you the answer. Okay, it's fine. It's okay. Right. Now, write the domain for f. We said this is an exponential function. B is greater than 1. So x is an element of real numbers, or x is from minus infinity to infinity. Or you can write it like set built notation like that. You see? So you must gain these marks. These are free marks, domain and range. You must know them. And then sketch the graph. We just want the intercept. We just want use the value of b for the shape, and then the asymptote. We have drawn the asymptote already, so it's a mark. This is 3 marks, isn't it? So we have 1 out of 3. Where is our next mark? From the y-intercept. We say the y-intercept for this function, for the function of the form f of x, is equal to b to the power x. The y-intercept is 0, 1. 0, 1. So that's the y-intercept, 0, 1 there. And then, is it an increasing graph or a decreasing graph? B is greater than what? Is greater than 1. So it is an increasing graph. That's the shape. Then done. We have our 3 marks. 3 out of 3. Done. You see that? Okay. Right. Let's just summarize our lesson. Well, before we go there, I'm going to give you 2 minutes to copy the homework. And then after 2 minutes, we summarize our lesson. Let's do that.
Believe in yourself. Believe a little more in yourself, because to those that believe, nothing is impossible. You have done this before. You have passed your tests before. You have went into a higher grade before. It is possible because you have done it before. Do not doubt yourself. Keep believing in yourself. Keep pushing, because this can be done and you can be great.
Thank you very much for joining us in today's lesson. Remember to do your homework. You're going to discover more shapes because we just talked about the two. Let me just show you. Right, we talked about the one which is shaped like this and the one which is shaped like this. Okay, right, you'll discover if you do homework, you're going to have another shapes which are like this, other shapes which are like this, and even shapes which are going to be like this. Okay, so now can you try to do your homework? You'll discover those. Just use your table of values and you follow your points. You'll have your graphs like that. Thank you very much, grade 10. We're going to meet in our next lesson. I really hope that you're going to have a nice holiday, rest, and make sure when you come next term, you are ready. Let's meet in our next lessons. Goodbye.